SpaceX's Starship Flight 8 faced setbacks, raising concerns about the program's progress. The launch, while initially successful, ended with the loss of the upper stage, following a similar issue in a prior flight. This latest setback emphasizes the inherent complexities in developing cutting-edge space technology. The focus is on the issues arising from this latest launch attempt and the need for a detailed analysis to understand the reasons behind the failure. The article provides context for the current state of the Starship program and the recent challenges in achieving orbital flight, emphasizing the complexities of large-scale space projects. SpaceX's Starship Flight 8, despite a successful initial ascent, encountered critical problems during the Super Heavy booster's return burn. 2 of the 10 center engines failed to reignite, a setback similar to issues in a previous mission. This section details a sequence of events highlighting the crucial point where engine failures prevented a controlled descent. The failure to reignite engines, possibly due to low power or igniter system issues, hampered the controlled descent sequence. The recurring engine problems underscore the need for thorough investigation and meticulous testing to identify and resolve these critical systemic issues. Further analysis will be needed to understand the specific causes of the engine failures, as well as potential solutions. The section emphasizes the recurring engine issues and their impact on the mission's success. Despite engine problems, the Super Heavy booster successfully landed, a significant accomplishment. This success demonstrates the system's enhanced precision and reliability in controlled landings. Upgrades to the booster's avionics, particularly its flight computer and battery systems, contributed to the controlled descent and touchdown. The successful landing, despite partial engine failures, highlights the progress made in refining the landing system. This section focuses on the positive outcome of the booster landing, emphasizing the improved performance of the system, which was crucial to successfully complete this phase of the mission. The improved system's precision and safety are key takeaways. The upper stage, Starship 34, experienced a catastrophic failure, marked by an engine fire. This likely stemmed from a leak in the engine's regenerative cooling system, leading to rapid engine degradation and a subsequent cascading failure of multiple engines. The fire's rapid escalation and the loss of control highlight the intricate interconnectedness of rocket systems. The section delves into potential causes of the fire, focusing on the critical role of the cooling system and the potential for cascading failures in a complex system like Starship's upper stage. This catastrophic failure underscores the significant challenges of developing a reliable and safe regenerative cooling system for high-performance rocket engines, crucial for future deep space missions. The fire's progression, from initial signs to complete engine failure, is analyzed. SpaceX is investigating multiple potential causes for the engine failures, including pressure fluctuations, combustion instability, and problems with the redesigned propellant distribution system. These factors may have interacted, leading to the catastrophic sequence of events that ultimately resulted in the loss of the upper stage. The investigation aims to pinpoint the precise cause of the failure. The analysis of the failures will guide future design modifications, aiming to prevent similar incidents. This thorough investigation will inform critical design changes and prevent recurrence, crucial for the future development of the Starship program. This section focuses on the investigation into the various possible causes of the failures. The Flight 8 anomaly yielded crucial data regarding potential system weaknesses, offering valuable insights unattainable through simulations or ground tests. This data is vital for refining future designs. Detailed analysis of the flight's telemetry data, encompassing engine performance, debris dispersal patterns, and other observations, will inform crucial design modifications. This incident provides invaluable lessons for the development of more robust and reliable spacecraft components. The iterative approach of SpaceX, using flight data to inform future design, ensures continuous improvement, crucial for future space missions. This section emphasizes how the data gathered from the incident can be leveraged for future development. What's behind the recent string of failures and delays at SpaceX? It has been an uncharacteristically messy start to the year for the world's leading spaceflight company, SpaceX. Let's start with the company's most recent delay. The latest launch date for a NASA mission to survey the sky and better understand the early evolution of the universe comes Monday night. The launch window for this SpaceX mission opened on February 28th, but a series of problems with integrating the rocket and payloads have delayed the mission nearly 2 weeks. Then there are the Falcon 9 first stage issues. Last week, a Falcon 9 rocket launched nearly 24 Starlink satellites into low Earth orbit. However, one of the rocket's 9 engines suffered a fuel leak during ascent. Due to a lack of oxygen in the thinning atmosphere, the fuel leak did not preclude the satellites from reaching orbit. But when the first stage returned to Earth, it caught fire after landing on a drone ship, toppling over. This followed a similar issue in August, when there was a fire in the engine compartment. After nearly 3 years without a Falcon 9 landing failure, SpaceX had 2 in 6 months. SpaceX has also experienced recent and recurring problems with the Falcon 9 rocket's expendable upper stage. On February 1st, a second stage deorbit burn failed after a Starlink launch. This led to propellant tanks from the stage crashing into western Poland, causing property damage but harming no one. It was the 3rd time in 6 months that SpaceX had encountered an issue with the Falcon 9 second stage. Finally, and most publicly, the company's massive Starship has failed on its last 2 test flights. Although the vehicle's first stage performed nominally during test flights in January and March, returning safely to its launch site, the Starship upper stage exploded spectacularly in flight twice. On both occasions, a fire developed in the engine section of Starship, and the vehicle rained fiery debris trails over the Bahamas and other nearby islands. Air traffic controllers diverted or delayed dozens of commercial airline flights flying through the debris footprint. Putting this into perspective, these issues have occurred against the backdrop of a largely successful and unprecedented launch performance. For all of the problems described earlier, the company's only operational payload loss was its own Starlink satellites in July 2024 due to a second stage issue. Before that, SpaceX had not lost a payload with the Falcon 9 in nearly a decade. So SpaceX has been delivering for its customers in a big way. SpaceX has achieved a launch cadence with the Falcon 9 rocket that's unmatched by any previous rocket or even nation in history. If the SpaceX mission launches tonight, as anticipated, it would be the company's 27th mission of this year. The rest of the world combined, including China and its growing space activity, will have a total of 19 orbital launch attempts. In the United States, SpaceX's historic launch competitor, United Launch Alliance, has yet to fly a single rocket this year. In fact, the company has not launched in 156 days. During that time, SpaceX has launched 64 Falcon 9 rockets. So yes, SpaceX has had some technical issues, but it is also flying circles around its competition. The recent failures are also unlikely to jeopardize, at least in the near term, SpaceX's globally dominant position. The company provides the Western world's only human access to orbit, and that's unlikely to change for a while. SpaceX launches the vast majority of NASA's science missions, and until United Launch Alliance's Vulcan rocket becomes certified, it remains the U.S. military's only way to get larger payloads into space. The company also operates a global internet network with more than 5 million users, and that number is growing rapidly. All the same, these recent failures may be telling us something about SpaceX. What is causing this? Without being inside SpaceX, it is impossible to put a fine point on what precisely is happening to cause these technical issues. Probably the most significant factor is the company's ever-present pressure to accelerate, even while taking on more and more challenging tasks. No country or private company ever launched as many times as SpaceX did in 2024. By way of comparison, NASA launched the Space Shuttle 135 times, a comparable number to the total of Falcon 9 launches last year, 132, over a 30-year period. At the same time, the company has been attempting to move its talented engineering team off the Falcon 9, in Dragon programs, and onto Starship to keep that ambitious program moving forward. To put it succinctly, SpaceX is balancing a lot of spinning plates, and the company's leadership is telling its employees to spin the plates faster and faster. Multiple sources have indicated that the Starship engineering team was under immense pressure after the January 16th failure to identify the cause of a harmonic response in the vehicle's upper stage that contributed to its loss. The goal was to find and fix the problem as quickly as possible. Let's step back and appreciate that Starship is an experimental system, by far the largest and most powerful rocket ever flown, and it catastrophically failed in January. During a span of just 7 weeks, the Starship team had to study the failure, address any problems, and prepare new hardware. How much of this is on SpaceX founder Elon Musk? Some have suggested his deep involvement in the 2024 presidential election, oversight of the Department of Government Efficiency, excessive social media activity, and more, like picking fights with U.S. senators, have distracted him from the problems of SpaceX. And there's no doubt that Musk has been focused on things other than SpaceX for the last half year or longer. However, in Musk's absence, he has capable lieutenants such as Mark Juncosa leading the way. SpaceX has long had a hard-charging culture instilled by Musk since the founding of the company. Musk's modus operandi is to push his teams to reach some ambitious goal, and when they do, he sets a new, even more audacious target. It may be not so much Musk's absence that is causing these issues, but rather the company's relentless culture. It seems possible that, at least for now, SpaceX has reached the speed limit for commercial spaceflight. When you're launching 150 times a year and building 2 second stages a week, it's hard to escape the possibility that some details are slipping through the cracks. And it's not just the launches. SpaceX is operating a constellation of more than 7,000 satellites, flying humans into space regularly, and developing an unprecedented rocket like Starship. The recent failures may be signs of cracks in the foundation. What are the implications? So far, the consequences of these failures have not been lethal, but space remains a difficult, hazardous game. Re-entering debris from a Falcon 9 upper stage could have struck someone in Poland. God forbid a second stage could fail early in a crewed mission. The risks of serious problems with Starlink should not be understated either. There have been unconfirmed rumors in recent months of near misses between Starlink satellites and objects in low Earth orbit. Additional debris in this increasingly cluttered space would be disastrous. To date, the Falcon 9 rocket program has not been slowed down by these issues. It's perhaps not fully appreciated how utterly reliant NASA's human spaceflight activities are on the Falcon 9. It currently launches the only crew-capable vehicle in Dragon. However, a cargo version of Dragon also flies on the Falcon 9, and this is NASA's only way to get scientific experiments back to Earth. And for at least the next year, the only other U.S. cargo vehicle, Northrop Grumman's Cygnus, also must launch on the Falcon 9. Not just NASA, but every other space station partner outside of Russia depends on the Falcon 9 for human spaceflight activities. The rocket must fly, and fly safely, or the West will be grounded. With Starship, the recent failures are a significant setback. Although there will no doubt be pressure from SpaceX leadership to rapidly move forward, there appears to be a debilitating design flaw in the upgraded version of Starship. It will be important to understand and address this. Another launch before the summer seems unlikely. A third consecutive catastrophic failure would be really bad. For the space agency's Artemis program to return humans to the moon, Starship's problems spell more delays. Musk had already signaled in late February that a critical refueling demonstration will now not happen this year. This test is an essential milestone on the path to the moon, and its delay all but ensures the first lunar landing will not happen in 2027 as currently envisioned. Most likely, the back-to-back Starship failures will also cement the path forward for Artemis 7 and Artemis III to fly as planned, with crews flying on the Space Launch System rocket and Orion spacecraft.